A hollow right prism of equilateral triangular base of side 4 cm is filled with water up to a certain height. If a sphere of radius 1/2 cm is immersed in the water, then the rise of water is dash. Very good. Now, this question, for you to be able to see it clearly, let me just draw some diagram. So since the hollow right prism is equilateral triangular base, so it has equilateral triangular base. So let me draw triangle at the base. Let's say this is equilateral triangle, and this is how it goes. So don't mind my drawing. So now, if we fill this with water, so this, let's say this is the water, and then it's ahead 4 cm. Okay, base of the triangle is 4 cm. This is 4 cm. And you know that a right angle, an equilateral triangle has equal side. So here will be 4, here will be 4, and here too will be 4. Then equal angle too. This is 60 degree. This will also be, okay, this is 4 cm. This is 4 cm. This is 60 degree. This is also 60 degree. So we have 60 degree all round. Now, they said water is filled with water up to a certain height. We don't know this certain height. We don't know this height. Yes. They now said if a sphere of radius 1/2 cm is immersed. So if the immersed sphere of radius 1/2, so the radius of the sphere is half centimeter, 1/2 centimeter. Of course, the water here will rise. So the water here will rise. So this is the rise in water. Let me call this one H1 and call this one H2. So this is the rise in water. So this is mathematics, but certain principles of physics can be applied here. So, but I don't want to sound as if I'm teaching physics. Normally, Archimedes' principle tells us that the rise in water, the volume of the rise of the water displaced is equal to the volume of the sphere. So, but I don't want to sound like physics. So let's look at mathematics. If this rises, of course, that means the volume of this sphere, it is this sphere that causes, it depends on how large or how voluminous the sphere is. If the sphere is too big, if the volume is too large, that means the water will rise more. But if it is too small, the water will not rise more. So, notwithstanding, we need to know the volume of the sphere. So that will now help us to know the volume of the water rising, water displaced. Now, we can get okay, first of all, let's calculate the volume of the prism first. So, let's calculate the volume of, let's start with the volume of sphere. Volume of sphere will be equal to 4/3 pi r squared. So we are given the r as half centimeter. So let's put that. I have 4/3 times pi times r, which will be 1/3, 1/2 raised to power 3 per r cube, not per r squared, per r cube. So this will give me what? 4/3 times pi times 1/8. 4 here 1, 4 here 2. So this will give me 1/6 pi centimeter cube. This is the volume of the sphere. Now, let's calculate the volume of the water displaced. Okay, let's calculate the area of this base. So that will help us to know the area, the volume of the water rise that rose inside this. So the volume of the water that rose is just from here to here. In fact, all this side we don't need it. But you know that since this base is equilateral triangle, that means the equilateral triangle is uniform throughout up to the top. It's just because of my drawing. My drawing is not very good. So here too, the equilateral triangle base. So the height of this. So for this part, I will need to use the formula of sphere. I will need to use the formula of prism, where volume of prism that says base area of the base times the height. And don't forget the height here is h2. So let's first know the area of the base. Area of the base, since the base is an equilateral triangle, and of course, these two, we can use the second formula of finding area of triangle. Apart from half base times I can use half two side, and the two sides are radius. Half radius, the two sides are the same. These are 4 centimeter, 4 centimeter. That means half times 4 squared times sine 60 degree. So this will give me half times 16 times what is sine 60? That is square root of 3/2. Of course, this is 2 here 1, 2 here 8, 2 here 1, 2 here 4. So that will give me 4√3 centimeters squared. That means area of the base equal to 4√3 cm squared. Now from here, it is h2 that I want to calculate. So let us go further by equating this volume to the volume of the sphere, because the volume of the sphere that enters inside here is what causes the volume of the water to rise. So this is the rise in the volume. So that means volume of sphere will be equal to volume of the prism that rose here. So now I am going to be having 1/6 pi to be equal to volume of prism, which is area of base, which is 4√3 times the height that I'm finding. That means that height will be equal to 1/6 pi. If you divide both sides by 4√3, so divided by 4√3. So this will give me what? 1/6 pi times 1/4√3. So at the end of the day, I'm going to have pi all over 6 times 4. That's 24√3. If you check the option, you will see that option C is the best, is the correct answer. And this is in centimeter cube. Thank you. God bless you.